Good evening, ladies and gentlemen. It is with great pleasure that I welcome you all to our interactive session on, the first we are doing this month. The topic of the session today is on generative AI and how it revolutionized industries with specific focus on the legal industry. We have today with us Mr. Animikh Roy. Animikh is the founder and the chairman of Wishtail AI. It's in India and in the US. He will discuss on generative AI in legal research, documentation, and case predictions, amongst others. Let me introduce Animikh to you. Animikh is the chairman, as I just told you, of Wishtail's AI. He is also an astrophysicist and an AI consultant. Animikh is an expert in building AI products and has an extensive background in neural nets, data science, astrophysics, topology, and graph theory. His passion and proficiency mainly lie in STEM, which is science, technology, engineering, and mathematics, oriented interdisciplinary applications of physics and mathematics and AI. Roy is a transhumanist thinker with synesthesia and a Mensa score, which makes him exceptionally gifted. Animikh firmly believes in the transformative potential of generative AI, envisioning its capacity to amplify and unleash the creative genius residing within children and young adults alike. So, I welcome Animikh. Animikh, thank you for joining us. So now I call upon our senior associate Mahima to brief us about the topic and the occasion.
Good evening, everyone. This is a very, very important day for all of us at Fox Mandal because we are restarting our continuing learning and education program. And we are extremely grateful to Animikh over here, who has agreed to take out time from his extremely busy schedule and deliver this lecture for all of us. Now, I think as we all venture into this generation of AI, we have to bust a lot of myths, especially about the capabilities of AI, its strengths, weaknesses, and its application to our life. Like Animikh always tells me that the WhatsApp University has done a lot of harm to our understanding of AI. And he is primarily going to help us unlearn a lot of information and relearn facts and truths about artificial intelligence as it is applicable. Now, for a law firm, especially a law firm with a legacy of more than 125 years, why is this so relevant today? And for that, I think I can only do justice to this answer by first giving you a brief background about how we have survived over 125 years and many such transformations, including the internet boom, including the revolutions, including independence movements, and at the same time we have survived as a law firm by adapting to change. And today, artificial intelligence is nothing but yet another change knocking at our door. And Fox Mandal is, again, going to embrace this change in order to become better and adapt with it. So, before we jump into this world of artificial intelligence that Animikh is going to take us through, I would like to show all of you a small glimpse of this firm's legacy and history in order to understand how its adaptability through the years has enabled it to reach where it has today. And in that, I think it would be important to mention that 125 years of an Indo-British partnership which has survived, has also been celebrated by the India Post by release of a first day cover and my stamp. And these small victories or these small milestones in the firm's history will continue for the days to come as we embrace the future. And just a small video to take you all through the journey of the firm and the making of this stamp before we tune into the futuristic world of AI. So over to the team for showing all of us this small clip.
More than a century ago, in 1896, or maybe a year later, two young attorneys, Mr. John Kerr Fox, an Englishman, and my great-grandfather, Mr. Gokul Chandra Mandal, came together to establish a firm of solicitors, Fox and Mandal, India's oldest firm, which remains integrally connected with at least one of its founding families. Legend has it that the two men, one barely 30, the other even younger, met at the Freemasons' Lodge in the city as members of the Fraternal Oath-Bound Society. Fox and Mandal was thus established down the vibrantly bustling street beside the Calcutta High Court at 12 Old Post Office Street. F&M, one of India's maiden law firms, has conducted uninterrupted business for 125 years from the very same location ever since. Following John Kerr Fox's demise in 1921, his son, Harold Fox, passed his rights in F&M to Gokul Chandra Mandal. After the death of Gokul in 1930, the firm was led by his only son, Sudhir Kumar Mandal, an illustrious member of the legal profession and the solicitor of the Government of India in Calcutta for over 25 years. Sudhir Kumar Mandal ably steered the firm with S.K. Mukherjee, a popular figure in Howrah, and a future Speaker of the West Bengal Legislative Assembly, and S.P. Mandal until his demise in 1988. A succession of illustrious frontrunners have followed F&M's founding leaders, creating new avenues of steadfast growth and making significant contributions to the business ecosystem. Today, the third and fourth generations of the Mandals continue to champion F&M's legacy of trust, innovation, and teamwork. F&M now has expanded its footprints to the National Capital Territory of New Delhi, where the office is being set up in the firm's building, F&M House, at Defence Colony, with 18 partners across 3 offices in 2 cities, Kolkata and New Delhi, who provide comprehensive solutions to clients on a wide range of issues. Fox & Mandal is aiming to continue on its path of growth and expansion. Over the years, Fox & Mandal has transitioned itself from a family-owned entity to a fully professional organization. As a tribute to the firm's heritage, the present keepers of Fox & Mandal's destiny were delighted when India's Post agreed to release a stamp and first day cover to commemorate its founding. Every stamp has a story to tell. This too does. But to condense the legacy of 125 glorious years into a graphic on a stamp can be daunting. So Debanjan Mandal, a managing partner of the firm, reached out to Abin Chowdhury, founder of Abin Design Studio, whose work focuses on the idea of holistic design through multidisciplinary collaborations.
This is very interesting and very challenging because the Fox and Mandal will be reviving their own logo, and that logo has to be kind of celebrated through stamp, and that's a very rare opportunity for anyone and any designer to design it.
As we weave in the stories of 125 years, the city in which the firm thrived and the pillars which held up its foundation, the people, the society, its rich cultural heritage and humanity, and the image starts to evolve. The stamp tries to link Fox and Mandal's past with its continuing story of growth and adaptation in a changing world, while the sepia-tinted motif seeks to offer a glimpse of the city's legal heritage. The sketches of some of the columns of each side of the main gate of the High Court, with its figures signifying justice, reassurance, and learning, formed part of the backdrop of the first day cover. It is in this fusion of past and the present that the impetus for the future lies.
India Post releasing a first day cover to commemorate the 125 years of the firm was indeed a moment of great honor for us. The designing of the stamp, the first day cover, and the whole process was very engaging. The stamp carries sketches of our founders, the first day cover carries sketches of columns of the High Court and the relevant motifs. I am indeed happy that the cover is being finally released by India Post.
Note, I request Animikh to please take over and give us the lecture.
Thank you very much. I'll just test the volume for a second, and then I'll begin. I'll just try to control it. Yeah, perfect. Okay. Okay, good evening, everyone, and welcome to this talk. I would first of all like to congratulate Fox Mandal for completing 125 years of its glorious history here, and thank Mr. Debanjan Mandal, who's like an uncle to me, for giving me this wonderful opportunity to come in front of all of you and present today. I can see my father's joined as well. Interesting. So, probably. Yeah, probably. So, on that note, I'd like to welcome all of you to a very interesting topic today. In fact, to the dawn of a new era, a brave new world, where artificial intelligence is rapidly changing every section of the society and is evolving at a pace that is challenging for each industry to catch up. So, first of all, before addressing what generative AI is and how we can understand each different unique concept in generative artificial intelligence, I would like to delve into the overall hype and impact that generative AI has created in the modern world today. So let us start with the hype and overview. And on a lighter note, I just wanted to sort of have an example to showcase to all of you, in the sense that generative AI is not only permeated itself across all our industries, but has also become the most searched keyword in Google, and to the extent that each Google presentation is now full of more than 100 such mentions. On a very funny note, when a supercut was made, sorry? Oh. Hello? Is this better? Oh, okay. Yeah. So, yeah, on that note, I just wanted to showcase how generative AI has kind of made itself evident, omnipresent all over media. And when Sundar Pichai did his last Google presentation, a supercut of the presentation left only these keywords as follows.
Generative AI, generative AI, AI is AI, 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 AI. It uses AI to bring AI, 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 AI.
So this was just a joke. So the entire talk can be summarized with the keywords AI and generative AI. That's what the world has come to today. However, basically, coming back to the serious conversation, And also, I'd like to inform all of you to feel free to raise any questions and stop me so that I can delve deeper into the topic as I go through one slide after another. So generative artificial intelligence is revolutionizing the way we approach complex tasks in the 21st century. And GAI is growing as well at a superbly exponential rate. So I'll just showcase some relevant examples related to that. On March 2023, we had our first inflection point in generative AI. This is for the first time that a content creator's entire job could be outsourced to ChatGPT with the GPT-4 model. In fact, on 14th March 2023, the world changed forever because we started taking artificial intelligence to the next level such that it not only could augment people's jobs, but almost replace them. And the way it has evolved is extremely surprising. So 3 months down the line, let's look at generative AI. So we go from a language model in March 2023 to an image model. So you take a snap of an image and then you enter a text. So this is combining both image and text models together. And basically, you can now transpose your toy car into a cinematic photograph, as you can see, within 10 to 15 seconds. So this is just the evolution that has happened between March and June 2023. Let's go 3 months down the line, and we come to September 2023. Now, as you can see on the left, it probably you can see a TikTok dancer, and on the right, it looks like Michelangelo's David, but it actually has been trained to model the TikTok dancer in real time. And the algorithm was trained on Michelangelo's David. So this is just one of the examples, but we'll go through a supercut of a couple of them. You'll see all of them quite relevant. So there's going to be C-3PO from Star Wars, and then some steampunk animation. All of it is able to capture the subject in real time and transform it. So here goes.
Baby, I'm a gangster too, and it takes two to tango. You don't wanna mess with me, baby, I'm a...
So as you can see, generative AI is evolving at a pace that it's extremely difficult to catch up with, and we can only imagine what's going to happen in the next 3 months by December 2023. With that, let us start from the very beginning to address what generative AI is. So generative AI is basically a subset of artificial intelligence that autonomously creates content such as text, images, voice, music, animation, or art. I'll try to showcase as many examples as possible as we go down the line, but these more or less encompass all the generative AI models that we are going to discuss not only today, but are relevant so far in 2023. So how do they sort of like work? And the basics can be figured out from our understanding of a specific type of generative networks known as generative adversarial networks, or GANs. So generative AI leverages pre-trained algorithms such as GANs, which are generative adversarial networks, to produce novel outputs with explicit instructions. Okay, so without explicit instructions. So basically, you don't have to train the model while you want the results. You can just type in, and it will give you the results like a genie. So instead of me going into a detail of how or what generative AI is, let's actually ask generative AI what generative AI is. So this is Emily, one of the fine-tuning models that we work with as a part of Synthesia.io. It's openly available for all of you to give it a try, but you can have conversations with Emily in real time and then address Emily to answer some pertinent questions like the one Emily will address right now. So what is generative AI, Emily?
Hey everyone, it's Em again. In today's 1-Minute AI concept, we're exploring generative AI. Generative AI is a subfield of artificial intelligence focused on creating new content or data, such as images, text, music, or even 3D models. It involves training AI models to understand patterns and structures within existing data, and then using that knowledge to generate new, original content. One popular type of generative AI is called generative adversarial networks, which consist of two neural networks competing against each other to create increasingly realistic outputs. Generative AI has numerous applications, from creating art and music to designing new products and generating realistic training data. As this technology advances, it's unlocking new possibilities in creativity and innovation. Thanks for joining me, and stay tuned for more AI concepts explained in just 1 minute.
So with the basic understanding of generative AI, we'll now delve into neural nets and how they are different from generative adversarial networks to give you a breakdown of what neural nets are from its basic level into the most advanced architecture. So neural networks are basically computational models that are inspired by the human brain's interconnected neurons, which are designed to recognize patterns and make decisions. They mimic biological neurons by processing and transmitting information through layers interconnected with nodes and biases and activation functions. So we'll go through each of these as we address them in the diagrams. So on the left, you have a biological neuron with a dendrite, a cell body, and an axon. And it basically encompasses the entire mathematical structure that is represented on the right. This is known as a basic single-layer perceptron model. A perceptron model is a mathematical modeling of how a neuron is activated in the human brain. And you have inputs coming in with weights. There are nodes, and then there's activation functions and an output. Now, if you look at the one on the left, let me just try this. Probably, yeah. Okay, so it's difficult to showcase it. Anyways, we'll continue. So on the left, you see the cell body, which contains specific, so each individual neuron has its own weights, and the input that it takes in is basically an electrical signal. It could be you triggering a memory, you trying to figure out a task, and that is the same input that goes into machine learning, and you kind of either learn things, learn to classify things, or apply them to solve complex problems. And then it comes to the fact that our artificial neural nets contain things such as biases and activation functions. So biases are basically, so the easiest metaphor to understand biases is our basic prejudices and beliefs that we have in our day-to-day world help us model the world outside. And as we create a mental framework, we're able to understand the world better. So adjusting the biases in a neural network help the neural network create a mental framework to understand the complex task that it is learning in a better way. Now comes the activation function. So activation functions are basically taking in a particular input and deciding whether that input will pass through or not. And the activation functions get triggered according to a neuronal state. So, for example, if a human is like really, really stressed out, our activation functions go either really high or really low. So either we are hyper-reactive or we are super depressed because of stress, or we are absolutely inactive. And because of that, the mathematical modeling of our activation functions change. So there could be a binary activation function such that, suppose if the input is 1, it converts the input to 100. And why is this important? It's important for us to understand threat detection. So similarly for AI, to understand and learn models, it needs to understand what is critically important versus what is non-important from the data. And in most cases, AI is going to be applied to security use cases, threat analysis, and all of fraud detection, all of that as well. So they need to understand and distinguish great threats from normal use cases and be able to apply them towards their machine learning components to learn and classify various examples as they go forward. So it's important to create what is known in mathematics as non-linearity in the model. So why is non-linearity important? Because if you basically model this, I think everyone has addressed this equation in school, y equals to mx plus c. This is the equation that comes in from the one on the right if you just subtract the biases and the activation function. So basically it boils down to linear regression. So when you are applying linear regression, complex tasks and complex problems cannot be solved, nor can you distinguish across classes with the efficiency that a normal human brain does. And that is the reason that these two come in, which are biases and activation functions. And these two complications make our neuronal network framework exactly behave like the human brain. Now moving on, we'll have to address what generative adversarial networks are. So before I give you a deep dive into the clip, just imagine, basically playing chore police. So the generator network always tries to generate something that will be indistinguishable from something that humans have generated. Okay, so whether that be an art form or whether that be sort of like a music production or a video. In this particular case, it's trying to sort of print money, and it's trying to make fake money look like real money. So I don't know if any one of you watched Fuzzy by Shahid Kapoor. Yeah, so basically that's what the generator network's trying to do. And then the adversarial network on top of that is playing the police's role and trying to detect that, okay, this is not authentic and therefore it cannot pass through. So the idea of GANs is to optimize for a game. It's basically a component of game theory. So you pass this game when you're able to fool the police successfully or fool the authorities successfully. Then you've trained the models to its highest form of efficiency, and then there's nothing else to worry, and then the tasks would be simpler. So let's see how this can be sort of broken down with a particular example.
A classic GAN architecture will have a generator trained to generate the image and a discriminator used to measure the quality of the generated images by guessing if it's a real image coming from the dataset or a fake image generated by the generator. Both networks are typically composed of convolutional neural networks, where the generator looks like this, mainly composed of downsampling the image using convolutions to encode it. And then it upsamples the image again using convolutions to generate a new version of the image with the same style based on the encoding. Then the discriminator takes the generated image or an image from your dataset and tries to figure out whether it is real or generated, called fake. This is repeated numerous times with all the images we have in our training dataset. Once the training is done, you can send an image to the encoder and it will do the same process, generating a new and unseen image, whatever the task.
So basically, with the help of such a logic, we are able to create art forms that are indistinguishable from what humans generate. Same goes with video, music, and images. And in order to understand how generative adversarial networks are applied in the modern day world, we'll delve into two specific examples. So the first example is generative pre-trained transformers. Can anyone guess what this is? What this model represents in today's world? Because it's omnipresent. Hint, Microsoft. The hint is Microsoft's product. What is it that uses a generative pre-trained transformer? You purposely called it generative pre-trained transformers instead of the short form, which has been popularized today. Any guesses? GPT. Right, yeah. So this is basically the architecture that ChatGPT uses. So generative pre-trained transformers start encoding data by doing something like as simple as crawling Wikipedia, okay? So each Wikipedia page is a parameter, okay? And then they will go through, after finishing all of Wikipedia, it'll understand how different topics are related to each other. And then from there, it'll scale to every page of Google, okay? And right now, the kind of data that GPT-4 has gone through is absolutely mind-boggling and remarkable, because as you are able to see, I mean, before I show you the graph, I just wanted to tell you that GPT-2 or GPT-3, or there was another transformer model, which basically had crawled through all of Wikipedia and gone through Google search, known as the Turing natural generation model. All of them reached up to close to 70 billion parameters and 40 billion parameters respectively. And that was enough to address most of the data and different variables that are available on Google. But then there is also industrial data and various other forms of data, which gives you the expertise to take up and take over a job, which previous transformer models could not do. And ChatGPT burned $1 billion USD per month to exhaust all global resources to reach this inflection point in March 14th, 2023. As they say, beware of the Ides of March. So that is ChatGPT 4. And GPT-4 now has trained on 1 trillion parameters. So that is almost 3 orders of magnitude more than the usual competitors out there. And even if you look at the other model before GPT-4, that is Google's Palm. And that is why all of the models that Google uses today, and even with Google search and Google being a predominantly AI-first company, they are falling behind with Bard, and GPT-4 has just taken up all the industrial data that Azure had, Microsoft had on cloud, and then just trained itself to perfection. What is the impact of this, and how can we measure it in the real world? So, so let's look at actually taking test scores with respect to GPT 3.5 and GPT 4's performances. And here's something very interesting to note out here, in case you haven't detected it from the x-axis already. That is the uniform bar exam, and GPT-4 just soars through it. So, in fact, a lot of people in the United States are leaving tuition completely to just train themselves on GPT-4, and then they're passing bar, not just passing bar, but then they're going through the exams with flying colors. Because the way that it can train you is much better than going through lectures, because this will be more driven towards understanding the concepts from a Q&A point of view. And also, if you are looking for some data points that you have to search several pages of several books, it already has it ready for you. So it becomes quite easy not only to learn law, but also new languages for that matter, and any new concept that you're going through. And the only place where GPT-4 sort of falters right now, during the time that this graph was made, in fact, that has been improved currently, because GPT-4 has now been combined with Mathematica, and it's doing all of mathematics perfectly. I mean, as a physicist, one of the hardest things that we ever do are Feynman path integrals. And I was able to combine GPT-4 with Mathematica and just give a simple line input and get a Feynman path integral, which would have taken physicists 7 to 10 days to crunch in 30 seconds. So now we've gone through all the text-based models, and specifically GPT. Now we'll look into another form of generative adversarial networks known as latent diffusion and stable diffusion models. These are responsible for the non-text models that you see today. So everything from DALL-E to Midjourney, all of them use some form of diffusion, okay? Now this is related to the physical concept of diffusion. So latent diffusion refers to the process of evolving a random noise into structured data and using iterative refinements, often applied in generative image or generative video models. And then stable diffusion ensures, it's basically an evolution of latent diffusion. It ensures a guided process of consistent and reliable generation across various iterations. And I'll demonstrate this with a video example, because this ultimately is related to an image or a video generation model. So breaking it down with a video example is the best way to go forward. But just imagine the diffusion of particles which spread randomly because of Brownian motion, resulting in noise. So if you start with a stable image, and then just keep on adding noise to it till it's absolutely indistinguishable. And then you train the network to rederive another form of, say, for example, you start with a golden retriever, then you reach absolute 100% noise. So it's just the static. And from there, you rederive it back to a Labrador. Initially, you just train it back to a golden retriever, and then you rederive it back to a Labrador. And what Stable Diffusion does on top of it would be to sort of guide it through transformer phrases from pre-trained transformer models, etc., so that instead of random motion of these, like sort of the paths that the neural networks take in order to evolve these models, neural networks take more guided and a stable approach for faster generations and better outputs. So we'll just delve into the topic with a video now.
For example, a drop of paint in a glass of water. The density of the paint after you just dropped it is very high in one spot and 0 in other parts of the water. By the laws of physics, the drop will diffuse into the water until it reaches an equilibrium. In the physical world, reversing this diffusion process is simply not possible. But with diffusion models, the goal is to learn a model that can reverse this process and bring the drop of paint to its original state, the noise adding to be reversed later. So at the end, a diffusion model is a Markov chain where in each time step, we add a little bit of noise to our image until the image only consists of noise, and later learning how to reverse this noise adding process. After it is trained, given only noise, this model is able to generate high resolution images.
So now that we've understood all the kinds of transformer models and generative adversarial models that encompass all of generative AI today, we'll go into some specific industrial applications where generative AI is revolutionizing the individual industries. And one of the biggest revolutions that generative AI has brought about in 2023 is in the field of medicine. So generative AI is revolutionizing medicine by enabling precise protein structure predictions. This is one of the hardest problems in all of biochemistry in its history. It has been achieved by Google and DeepMind's AlphaFold. DeepMind is a company that is owned by Google, which has solved a 50-year-old standing Nobel Prize-worthy problem. So if a human being had solved this, they would have gotten the Nobel Prize this year, which has been an unsolved challenge in biochemistry, medicine. So now we know more than 200 million ways that proteins can fold. And next time we have a pandemic, our precise drug prediction and solutions would be instant and rapid instead of having to wait for months to get the exact solution. So that just came out 2 months ago, and it's been revolutionizing medicine ever since. Let's see what Google has to say about it.
What started out as a 50-year-old challenge is now possible through DeepMind's latest innovation, AlphaFold, a deep learning algorithm that has predicted nearly 214 million protein structures, up from the previously known 1 million. That's 200 times. It's revolutionized the scientific community to help create life-saving treatments to diseases like Chagas. In fact, these predicted structures are available as a part of the no-cost public datasets program so that you can run custom queries on BigQuery. And now you can run AlphaFold reliably on your own by using these available solutions on Vertex AI. You can try it out first using our solution on Vertex AI Workbench, which includes a Python notebook and containerized hosted environment to make protein predictions using a genetic database.
Google has basically outsourced this and like sort of open sourced the initial subscription to the model and given all scientists a 30-day free trial to try AlphaFold and come up with their own drug predictions for absolutely free. And each of us can access this model via the Google Note collaborations. Next, we come to generative AI in the software business, and that has been a revolution more or less since March 2023, but with a few other important iterations since June. And since Microsoft has acquired ChatGPT and OpenAI, therefore, it has embedded it into its GitHub environment to now completely transform how software businesses work and how product development, automation of tasks, and generating code works. So GitHub Copilot is a revolution that has not only doubled or tripled my individual productivity, but it has 10 times increased my productivity. Basically, it helps you complete autocomplete code, give you suggestions, and run tasks in automation, which would have taken hours to complete at a stretch. So let's see what Microsoft has to say about it.
GitHub Copilot is an AI pair programmer that we built to help you rediscover the joy and creativity of coding. By drawing context from comments and code, Copilot suggests individual lines and whole functions instantly. It's currently available as an extension for NeoVim, VS Code, Visual Studio, and the family of JetBrains IDEs. Copilot handles low-level tasks and common problems like scaffolding new code and APIs, building regular expressions, or even working in unfamiliar programming language. Copilot helps you stay in the flow by quickly offering a variety of suggestions, new paths, and ideas for new frameworks. This lets you spend less time on boilerplate and repetitive code patterns and more time building great software. Copilot works for all major programming languages and is intelligent enough to adapt to your personal style over time. It can even help you learn new programming languages. To learn more, check out this link. Now, if only Copilot could suggest a cool way to end this video.
So that brings us to generative AI in law. Unfortunately, there is no one straight solution for generative AI in law yet. And there are various potential options. I don't know if any one of you are familiar with Everlaw. Are you familiar with Everlaw? It's a startup out of Silicon Valley founded by, I think, professors and lawyers from Harvard and University of Austin, Texas. And now it's trying to bring in a lot of process automation into law, but they do not have generative pre-trained transformer models into it. Later on, I'll try to give you a glimpse of what my product, Wishtails, can do in terms of helping in generative AI in law. But as of now, let's glance through the various impacts that generative AI can bring through in law. Firstly, automated document review. So generative AI can definitely speed up case preparations by analyzing thousands of documents quickly. Now, this batch processing has not been automated by any software yet, but it's been done for various other domains already. So law is just like ripe and waiting for a revolution. And this industry could absolutely be exponentially revolutionized with generative AI in terms of increase in productivity, as well as efficiency, and going through more work in shorter periods of time. Then you have contract generation. So it instantly drafts standard contracts, saving time for tailor-made clauses. I've given Mahima a few examples of this with our own generative pre-trained transformer models. And it is able to do so in, thankfully, very sensible ways, and also in multi-languages. Then you have predictive analysis. So generative AI can definitely help forecast case outcomes by using past verdicts and adding it in strategy formulation. So this is a huge part of the big data database. So if you have a platform as a service where you put in all your archival data, and then something that I personally work on is graph theory. So graph theory would help you link various topics with each other in a very unique manner. The best tool that I use is personally Obsidian, but something can be sort of extrapolated to create the same for the domain of law. And then that would be really powerful and fascinating for all predictive analysis in law. And then we have enhanced client services. So definitely chatbots have created a revolution across industries. And with all the legal knowledge that pre-trained transformer models have that can not only pass the bar exam, can fly through it, they can definitely help people go through like legal advice for a subscription and actually add to the revenue of a law firm, as well as handle multiple clients at a rapid rate, because they don't get tired. Generative AI is never tired, available 24/7, and is available for international customers. So no Saturdays and Sundays. Yeah, no Saturdays and Sundays at all, and continuously sort of generating revenue for legal firms. So what are the major impacts that generative AI can have in the legal industry? So generative AI could provide could prove to be impactful to streamline document review. It could automate the generation of legal drafts and contracts. It could also aid in predictive analysis, enhancing case strategy by forecasting legal documents based on historical data. So instead of hearing it from me, hear it from a professor of law at the University of Austin, Texas, in terms of what he believes the impact of generative AI could be in law in 2023.
If you're a lawyer, then you should be concerned about artificial intelligence and how it's going to shake up the legal industry. It is only a matter of time until AI can write fully briefed arguments. But what happens when law firms start paying subscriptions for AI services that can write legal arguments in seconds that may take the associate hours? Better yet, what happens when AI can start absorbing case law like that? Presumably, AI should allow law firms to reduce their expenses to an incredible amount because AI doesn't ask for a salary, doesn't ask for a bonus, and doesn't need benefits. Plus, AI doesn't eat or sleep, so it can continuously create output for the law firm. If I boil it all down, AI allows law firms to achieve more with less. And as a result, my prediction is that once AI comes into its own as a legal resource, we're going to see an exponential explosion of lawyers starting their own small law firm.
Okay, that's a prediction to keep in mind. So we move on to the risks and controversies of generative AI. So generative AI definitely poses a lot of risks. Anything that brings you so much power at hand would have definite risks. But one of the most potential or crazy risks that generative AI has is it has literal AI hallucinations. It's the only thing in the world that can have hallucinations without drugs such as LSD or ecstasy. So, for example, if you were to mention, if you were to have your biodata in a document that somehow missed your age, maybe has the date of birth, but doesn't explicitly state what the date is now, whether you're dead or alive, etc. And then you ask the AI model, specifically models like GPT-3, Google's Bard, all of them, what the person's age is on the document from the biodata, it will definitely give you an answer, and that is risky. GPT-4 doesn't do that. So if GPT-4 has another layer, which is kind of self-referential. So it will ask itself, so once it gets an answer, it'll ask itself, how did I get this answer? And with that additional layer itself, it takes more time, but gives you 100% accuracy. However, other than GPT-4, I've never seen any other model that has been devoid of AI hallucinations. And that's been one of the primary concerns of even people like Tim Cook from Apple. Satya Nadella has spoken about it, and mostly specifically Sundar Pichai, because Sundar Pichai's shares plummeted after Bard started hallucinating, and Google's shares fell by 15% in a single day. So that was a crazy thing to keep in mind. The other, obviously, major problem is deep fakes, and plagiarization of content is something that is blurry in terms of the models that are established out there. They will just take an art form from Van Gogh, okay, but they will not mimic the exact painting, and even if they did, it would be digital in form. What people have done using these styles and forms is create sort of like digital tokens for the Web3, and then sort of sold them out as NFTs, so non-fungible tokens. And on OpenSea, this is like a popularized way of making money. But apart from that fact, the major concern is deepfakes. So that has been specifically concerning for actors and actresses and famous people and celebrities. So AI can actually make you say things and make the video seem indistinguishable from reality. And that could be misused in various dangerous ways. Here's a professor from Stanford University talking about the pitfalls, risks, and controversies of generative AI today.
I think the hallucination is a real problem. As a family of technologies, we need to have a good answer to the question of how do you make sure that these things are verifiable? That's a really interesting opportunity for companies operating in the enterprise space. If you're doing creative writing, it's fine. But if you're building jet turbines, it's important that it's correct. I'm looking forward to and following closely the literature on correctness and verifiability.
Next, we have a very famous YouTube journalist who's actually been a Vox journalist her entire life and recently started her own YouTube science channels, one of the best science channels to follow, Cleo Abram. And she talks about these blurred lines that Mahima has discussed with me a lot regarding what could be plagiarized content, what is AI-generated art, what are the blurry lines, what are the implications on policies going forward.
This is the big controversy around AI art, explained in 60 seconds so that you can sound smart when people bring it up. So you've been seeing images like this, and you probably know that somebody created them by typing in a text phrase to an AI tool that looks like this. The big controversy about this is really actually two controversies. The first is this tool going to wipe out the jobs of designers and artists? Take a look at this. On the top, that was made by a designer at the media company Axios. On the bottom, that was made in just a few seconds by prompting one of these AI tools. The risk is that because these are so fast, that could be one person as opposed to 20. The second controversy is, are these AI tools stealing from artists? They get trained on images online, which means that you can use an artist's name and then replicate their styles. The question is that different from what we already let humans do when they get inspired by other artists or mimic their styles? Some people say it's the same because it's actually a new artwork just based on the style of the artist. Some people say it's different because it's actually taking the data from the artist's work and a machine is replicating the style. It's messy. Ask me your questions, I'll make more videos.
So this has no proper laws or regulations about it, but this is going to be a hot topic to debate and discuss in 2024 as we evolve laws specifically for AI models generating content and then people using that content to generate revenue and various other aspects. But apart from that, there's another technical problem with respect to like 20 jobs being shared by one person. And for us specifically, my co-founder at Wishtails runs a services company, Darshan, and he sort of chopped down his entire workforce by flat 50% since like July 2023, and his profits soared. That's specifically because he could just augment like most of the tasks and do it using generative AI models and do it in a professional way and would not have to repeat them several times and pass it on to consultants and other employees. So this is a practical implication that started in 2023, but its impact will be felt 2025 onwards. 2026 or December 2025 will have GPT-5, and once GPT-5 comes out, there is no returning, because I don't think anyone who doesn't know computer science or is a technical scientist who can push the boundaries to the next level is going to be super relevant in any job anymore, including the fact that there are 7 millennial problems in mathematics, which have taken hundreds of years to try to solve them each. And one of them intersects, so solving any of them would result in the only prize that is considered higher than the Nobel Prize. It's known as the Fields Medal in mathematics, and people can only get it below the age of 40. It's not given every year. It's given every 5 years, only when major breakthroughs are made, as opposed to giving the Nobel Prize each year. Now, the Poincaré conjecture in 2006 was one of the 7 millennial problems that was solved after 106 years of trying. And as you can see with the protein folding problem, one of the main things that GPT-5 is poised to solve is the Navier-Stokes equation, and that has been up for a Nobel Prize and a Fields Medal together, because it's the only major problem that intersects mathematics and physics together. And one of the things that GPT-5 is going to be applied to is these challenging problems that us humans can not only comprehend the solutions of directly, but it's a challenge to compute them even if we can comprehend. So what's going to be the future of generative AI and global policy? Let's take a look. So first of all, future of global policy drafting is definitely going to change. Generative AI would suggest global policies based on historical sort of data, and they would combine all the big data, trillions of data points from environments, and then region-specific regulations to fine-tune them. Something that would have taken humans years to do, they can do that in seconds. And that years to minutes or years to days is understandable. Years to second is like sort of like incomprehensible to the ordinary person. And that is a challenge that we'll be facing around 2025. But this is a good challenge to have, because then regulations, if these policies do help bring down climate control in a positive way and help reduce climate change and carbon footprint emission and make rapid changes in places that are remote, then definitely that is really helpful for both policy drafting and governance. In terms of governance, so generative AI can forecast societal needs, guiding proactive policymaking, such as the next, like preparing us for the next pandemic. Bill Gates has predicted that this is not the last pandemic that we face, and we could face a few more in this decade itself. So with the protein folding model and having access to generative AI models, we could definitely prepare better for the next big pandemic. And then that could be combined by involving individuals without sharing all our private data. And that can be done with a layer of generative AI that's going to work on top of graph theory models in what is known as Web 5. Now, I'm sure most of you've heard of Web 3. Web 5 is an extension of that concept introduced by Jack Dorsey, and Elon Musk is also behind it. It's as new as 14th June 2023. So Web 5 is basically a combination of the good pillars that already work in Web 2 and the decentralization of Web 3. So 2 + 3 = 5. And this has resulted in self-sovereign identities. We've already been using things like DigiYatra, and then we have had verifiable credentials such as Arogya Setu and like our COVID vaccination certificates. That's the largest implementation of verifiable credentials in the world, by the way. So India has been quite ahead in this technology, and we've been sort of paving a way towards that. So we will have a unique DID. A DID is a decentralized identifier, which will combine all our VCs. Our verifiable credentials are basically our passport, our Aadhaar card, our PAN, all of them will be mapped to a unique digital identity. And then that identity will be used for all verification purposes, mapped to your biometrics. So the data would never actually go into another cloud platform or get stored in another server. This will always be stored in decentralized web nodes, where decentralized web nodes immediately just combine this data and do a real-time verification. So how this happens is, suppose my name, like ANIMIKHROY, the first 3 letters get stored in one particular decentralized web node. The next 3 letters, this is obviously an oversimplified example, but the next 3 letters get stored somewhere else. And this also gets jumbled up. So there is a public key and a private key. Private key is mapped to my phone, and the public key is accessible in all of these decentralized web nodes. You combine them together to decrypt it and get the name, but this name never passes into, say, the Facebook database or the Google database or the Meta database, and hence it is completely secure. So this is all done using generative AI on top of the Web 5 concepts, and this definitely brings in the future of governance. Next, we have a public feedback analysis, so that generative AI can aggregate decentralized global citizen feedback. Again, I think the future of voting is entirely going to be phone-based, and because you have DIDs and VCs, so all you need is your biometric. You never need to go to voting machines, and no results can ever get manipulated. And public feedback analysis is an extension of that. Every policy, whether that be a local policy or a global policy, and even the voting structure and the process of having elections at longer intervals would not be relevant going forward, because you would have rapid decision making at a local level. Suppose you need to repair something and you approach a counselor today's process is slow, boring, as like non-tangible almost. And you would be able to access a form inside your phone, use your didn VC, and then all your neighbors could do the same. Once that petition passes through, it will not wait for the councillor's approval. It will go directly to the system, and the system will allocate funds from the government to get it resolved. And that is the future that can be really positive with generative AI. Then comes the future of international treaties. So generative AI can definitely facilitate real-time multi-language translation. Now that is very important. And it's been like a tremendous set of 4 to 5 months of nightmares trying to do multi-language translations for wish tales, but we've achieved 20 of them. And I know that it is quite difficult to get the same level of accuracy that you get in English in all of these language models, but I was very happy that Mahima confirmed that the Hindi draft that I kind of showcased her as an example yesterday, I believe it was a non-compete clause, yeah, it was completely written, was a good translation. I'll show that example later on. So that is definitely going to be a very quick conversion in terms of having to wait for big major decisions and formulations. So what are the final, we're kind of like reaching the end, but before that we are going into the required changes that's important for international law and policy for generative AI. So first of all, we need to revise copyright laws to address AI generated content, such as AI authored books and artwork. Who owns the copyrights for that? Does it belong to the AI company? Does it belong to the individual? These are up for debates, and that's what next year will be interesting to look at in terms of the horizon. And then in terms of data privacy, as I explained, DIDs, VCs, SSI combined with generative AI can definitely help strengthen the framework, but we need some strong regulations so that AI can't access personal data, because you can use the same models to probe into people's private data and get all the data from it. Again, recently, just 2 weeks ago, Darshan's entire Instagram profile was absolutely mimicked by a fraudster using generative AI. And not just that, his other handles were also mimicked to that same handle. The fraudster approached other people saying that their phone number had changed and sort of extorted 35,000 rupees in a single day. So these are problems that generative AI can definitely pose, and we need better data privacy to protect them. Then there's accountability frameworks. So clear accountability frameworks need to be established. And like I said, decentralization of finance is a big challenge, but once that is addressed, then suppose if AI made a wrong prediction, whether that be in medicine or whether that be in law, today we have no one to blame. And eventually, like AI's, like you can probably crash the server or beat it up, but that's not going to make a difference to the generative AI model. What you can do is have generative AI models get assigned a particular part of the budget that they control if they were making any wrong decisions. So money is sort of assigned from as compensation from that budget so that generative AI can be held liable for that. And decentralized finance is the way to go about it. Then obviously there's ethical standards. So implementing global guidelines for AI's ethical use, especially in sensitive areas like healthcare, is absolutely important because people's lives are at risk. And finally, generative AI needs to be way more transparent. Today, we know the applications and we know the mathematics behind it, but the way an AI reaches a particular classification, that path itself is a black box, because AI moves in random pathways to make itself learn, similar to our neuronal pathways. You can never, even using an fMRI, you can never say that for learning this particular problem, my brain uses this particular pathway, right? So, but in AI, there are certain things that we can do mathematically to make the models more explainable, more transparent. And that would help us understand what influenced a decision. So if there was any bias, such as racial bias in the data was one of the major cases this year. Most of the training data for various image models have been racially biased with white data. and therefore the adjustments that they do to people of color are absolutely not called for. And these biases can be understood much better if AI becomes explainable. So with that, we kind of reached the summary and conclusion. We've learned that generative AI is a subset of artificial intelligence that autonomously creates content such as text, images, voice, music, animation, or art. It leverages pre-trained algorithms such as GANs, GPTs, and diffusion models to produce novel outputs without explicit instructions. Then we've gone through some of the generative AI breakthroughs for this year. Medicine, it's AlphaFold. For software business, it's GitHub Copilot. In law, it's definitely coming soon. We never know when it might pop up. And then there's definite benefits in law in terms of automated document review, predictive case outcomes, enhanced legal research, and definitely client services 24/7 as discussed. The major risks that generative AI poses today are pertaining to AI hallucination and misinformation, and also deep fakes, which can be traumatizing for all of us. And then the required changes in global policy pertain to revised AI content copyrights, enhanced data privacy via SSIs and DWNs, which are decentralized web nodes, as I explained. And accountability for AI decisions need to be incorporated, both financially as well as at the model level using explainable AI. So generative AI offers vast promises to maximize our creative potential and productivity, but it definitely requires updated regulations and ethical standards to ensure its responsible use. While we conclude, I want to leave you with this very strong and promising thought that has impacted all of us working in AI, coming from a top-level boss like Sundar Pichai. AI, specifically generative AI, rivals fire and electricity as humanity's greatest discovery. Again, it rivals fire and electricity as humanity's greatest discovery. In fact, it could turn out to be more impactful than both. So generative AI is yet to reinvent fire, but we'll wait for that and see if Sundar Pichai is true. Thank you very much for your patience and for accommodating me. It's been a privilege to talk to you today.
Bias towards states. So whether that will also be considered by AI before giving you a prediction of the case that you are talking about?
So that entirely depends on whether those parameters are sort of like built into the training model. So for example, how is the judge's behavior captured? Whether that is purely in terms of verdicts and decisions is one. That is sort of data at the meta level that the AI model can guess that maybe the judge has these biases based on the verdicts under different circumstances, but more explicit data and background study could help, but that would also infringe in sort of like private data with respect to that person. So there will always be a fine line with respect to this, but what generative AI can ensure is, given the circumstances, in future, this is the best decision that's taken forward, looking at the bigger picture, which is often difficult at an individual level to do, because we cannot look into so many variables together and have a big data system in our head. So that is, again, in terms of assisting for major decisions, generative AI is great. For documentation work and all of that, generative AI can not just augment, it can take over the task entirely, as I explained.
I have a question, Animikh.
Yeah, sure.
Can AI or generative AI read a contract, which I can scan and upload onto the software? Can it read correspondence, which I can upload? Can it answer questions, which I will then say that basis this contract, basis these correspondence, who is right and who is wrong? And what is the answer to this question? Can it do it?
Yes, the answer is absolutely yes. And Fishtails.ai can also do it.
Forward to seeing that someday. So any other question from our audience on Zoom or YouTube? Yes,
Yes.
Sabina, you can be heard.
Loud and clear.
So, Animikh, thank you very much. It was a very nice session.
Thank you very much.
Enjoyed it thoroughly. A lot for us to chew on. My experience with ChatGPT so far, I'm a novice, is, what is fed is what's thrown out to us. My question to you is, will AI ever be able to create new legal documents that are more efficient and effective?
I just have one question before I explain the answer. Do you use GPT 3.5 or do you use the paid version of GPT 4? Okay, so then the only issue there that we faced while we were building Wishtails is that GPT 4 is able to give you accurate content and also new content. That is undoubtedly true. However, there is an entire prompt engineering layer that needs to feed information at a more critical and detailed level to the engine. Now, that is quite often very tiring and misleading for a normal non-technical user. And that is the problem that we are trying to solve with, one of the problems that we are trying to solve with Wishtails.ai, such that you put your prompt in, you choose a persona as a legal writer or a patent lawyer, and then based on that persona, the prompt is expanded by the transformed model itself into a very specific set of technical points or critical points that the model will then take in as clear inputs, understand it better, and then produce new content. So the answer to your question is, for GPT-4, with proper prompt engineering, it's absolutely possible. And we are trying to solve that problem without having to do explicit prompt engineering at the user level. Yes, absolutely. That's true. Thank you very much.
Hi, Animikh. I have a question.
Yeah,
so
absolutely.
essentially, in legal tech, there are two softwares mostly which law firms are using these days. One is your Luminance and one is your Kira. The problem and I would say drawback with these two softwares are essentially when you feed in contracts over there, like for a M&A due diligence or whatever may it be. So in those, the clauses, like if it's differently worded, it doesn't show up at times. So how does generative AI or Wishtail tend to solve this problem? Because we have seen that even if we upload 100 documents in place, but then they do not come up with the exact clauses, because in sometimes what happens, the clause references are different, there's no heading to those clauses, but the clause particular of the clause or what the essence of the clause is remains the same. But we as lawyers could identify those clauses after going through 100 pages of that document. But if legal tech is able to solve this, I think that's a very good in terms of how efficient we as lawyers would become when it comes to review of those agreements or documents in place.
Yeah. So the answer to that question is, I do not know the two softwares that you shared, and I'm guessing that they don't use pre-trained transformer models, because what normal softwares do is they use a layer known as Elasticsearch, which would use either the words exactly as it is as a string match, or synonyms of those words, or distorted spellings of those words. They don't have a module known as natural language understanding. If they do have a module known as natural language understanding, then suppose this is where legal contracts can go wrong. This is a very simple problem that GPT kind of solves. Suppose in the contract, it says that A is B's father and B is C's father. So A is C's grandfather, right? That is not written anywhere in the contract. So that is what NLUs understand perfectly when it comes to all broader aspects as well, which your current softwares will not be able to address. And that is something that I think, based on the contract, I think Mahima sent me a Hoichoi contract. And based on that contract, the specific clause that was drafted was not a random specific clause. It was drafted according to the contract for Hoichoi with the specific things that were extracted from the document. So there needs to be an NLU layer and then a generative layer. So since generative AI is 3 or 4 generations ahead of normal AI, how normal AI would deal with this problem was it would try to generate language without having the context of a lawyer. It would just generate language as a normal language generator. So suppose if I were to review the legal contract, I would write it like that. But the difference between that and a pre-trained transformer, specifically like GPT-4, which we have used to train our models as well, is specifically that they have gone through these billions of parameters from the perspective of a lawyer itself, of all legal data. And that's why they can bring in that expertise and perspective, and that is absolutely possible. The only thing is there's no current large-scale software that has brought about that revolution in the field of law, and it's ripe right now for that next revolution in law.
Thank you.
Oh, hi. You joined. Great. I can't see you. Oh, great. Hi.
What is the speed of this replacement and on what factors will it depend on? So, for example, like what we are talking about is that in AI, it is the efficiency or the correctness of AI will depend largely on the data that is fed into the system. So, in a country like India, where most of the legal work is still done on paper, it is not digitally done to a large extent. We have files, we have books, we have various other hard copy things. So will it depend on the availability of the data that it will take more time to replace in a country like India or other countries like this one where physical work is done, or will it be widespread all over the place in a similar manner?
The answer is it's going to be ubiquitous because it's already a pre-trained transformer model. All you need to do is, suppose the data isn't available digitally yesterday, suppose the data is available today, then it would be analyzing it like an experienced lawyer would, looking at the fresh data. So it has been trained and it has gone through all of these courses internally at Harvard Law and various other top places. It has developed what is very rare and was never in AI before, which is a form of domain-specific experience. Based on that, all it needs is the fresh data and then apply its pre-trained understanding. Previously, what used to happen is, when you put in fresh data, you'll have to retrain the model again. This retraining concept has gone, and that has just gone since 14th March. So it's absolutely fresh and new. Before that, even with GPT-3 or GPT 3.5, you had to do significant amount of retraining. Wasn't efficient enough. But with 1 trillion parameters, and I recently heard that the 1 trillion parameter training has exceeded 10 trillion by today. 1 trillion was in March 14th. By today, it's 10 trillion. And apparently, GPT-5 will come out with 100 trillion parameters. So there's only, I think, 1 exabyte of data by 2025. And data is different from parameters. Parameters are variables, such as your names and topics, etc. So 1 exabyte of data can be matched, completely mapped with 1 petabyte of parameters. So, I mean, GPT-5 will already be like a tenth of controlling the global data. And the next generation after that would have control of all the data that's ever been generated. The funny thing is, the more people depend on generative AI models to write emails or to do all of these contracts, it would be generative AI models generating the data and then generative AI models reading the same data that it generated. So just from March 2024, 20% of the data on the internet, 20% of the data on the internet is through not specifically GPT, but generative AI models. So it's learning from its own data and shaping up its own future. Thank you very much.
Good evening. It gives me immense pleasure to deliver the vote of thanks after this fascinating talk on generative artificial intelligence by Animikh. Thank you, Animikh, for sharing your experience and your knowledge with us, and also enrich us on the topics, which is generally known to everybody, but we are yet to implement or yet to deep dive into the system or deep dive in the knowledge of this AI. I would also like to acknowledge and appreciate everyone who was behind this session. First of all, I would like to thank Saviana, our Chief Management Advisor, Khushbu, our strategy officer, Surya, our chief technical officer, Mahima, our senior associate, Sumit De, and Mr. Bose, who have helped us in organizing this session. I'd also like to thank all my colleagues who are present here and also outside and also in other office spaces who have been very helpful in engaging and participating in the session so that it can become a more effective session. So I'm sure with the knowledge that we have shared here and the insight gained from the sessions will help us in our future to help us in future use AI in our daily life. Last but not the least, I would like to thank our managing partner, Mr. Devanjan Mandal, to organize this and help us. Everybody is, and therefore I thank everybody once again, and hopefully we'll continue with this informative session in future.